Hello, this is Paul from Foresight Tech. In this video, let's prove Theorem 3.5.1, part 3, the last part. And this theorem gives us the relationship between cross product and dot product. And this part, so we call vector triple product. Vector triple product, okay, so D and E give us a method or a tool to calculate the triple product. So what is called, we call triple product, because this product, the answer we get is a vector. Okay, so we call it vector triple. Okay, vector triple. And if we change this cross into the dot product, and this vector, if dot, we get a scalar number, and that one we define as a scalar triple. So here we deal with vector triple. Okay, that's the name. D and E are very similar, right? Very similar. We can directly verify D. Okay, do a lot of calculation. I will use other tools to find E. Okay, so we can leave the verification for D. If D is correct, we can easily use D to prove E. Which tool we need? We just switch the order, which is anti-commutative. Okay, so we use Theorem 3.5.2. Okay, anti-derivative, anti-commutative. So let's go to E first. Verify. So E. So first we go from the left. The left, which is U cross V cross W. See, if I need to use the result of D, we have to switch. Okay, so switch the order, switch these two order, and that's a anti-commutative. Okay, so we cannot directly switch. After switch, we need to get a negative. We need to get negative. And then put the name. So Theorem 3.5.2 give us that's a property. It's an important property, anti-commutative. Okay, and then I can use D, right? So we use D, and then see what do we get. We use the result D. So it should be U minus V, right? Dot the vector. Directly use, which is a negative. Let me put a parenthesis here. So the first, okay, W times the second V. See, okay, the pattern is a V. Okay, the vector is a V minus W. The first minus the second. So the first is U, the second is W. Or is V. So here should be U, and then minus W dot the first, then times the second. Okay, so this is D. Think you're almost right. So we need to get a U dot V, U dot W. U dot W is here. Okay, so it's easy. You just distribute. Therefore, we have the results already. See, negative, make it positive, and then W dot U is U dot W commutative. Okay, so this is commutative, you know. Okay, we don't need to put the negative commutative. So this should be U dot W and V minus what? Minus V dot W times U, which is the result of E, right? We can compare. Okay, so E is correct. Now let's verify D. Okay, along calculation. So to calculation, we need to, whatever, both sides are complicated. So we do this way, the strategy. I work on the left. okay, toward the right, and I also work on the right toward the left. Therefore, they will meet in the middle. Okay, you see. So we calculate this first, and then U cross. So now here is D. We verify D. First, let's set up. Okay, U is U1, U2, U3. Of course, V vector is V1, V2, V3, and the W is W1, W2, and W3, and then we do calculation. We calculate the V cross W. What is V cross W? The definition is this. You know the definition. So we don't have V1, so V2, V3, right? W2, W3. First, the negative. V1, V3, W1, W3. Okay. And then the third component is V1, V2, W1, W2. Okay, so almost. So let me get it by the definition, which is V2, W3 minus V3, W2. Okay, and here is negative. Don't miss the negative. Therefore, it should be V3, W1, right? Okay, so V3, W1 minus V1, W3. The last is V1, W2 minus V2, W1. Okay, so I get this by the definition of 2 by 2 determinant. And then U cross. One more. A lot of calculation. You have to be patient. So U this time cross V cross W. See, we already find this. It's complicated. Let's note that. Okay, so let's say this is just B1, B2, and B3. Let's denote. So B1 is the first component, B2 the second component, B3 the third component. Okay, so therefore now this should be what? Should be this. How to put it? So the first, which is U2, U3, and then we use B to describe this, right? So this is like a B, okay, like B is there. So B is B2, B3, of course, and then negative U1, U3, B1, B3, and then U1, U2, B1, B2, B2. That's the definition. And then we do calculation. Break it down. So it's a U2, B3 minus U3, B2. The first. The second, don't miss the negative, which is U3, B1 minus U1, B3. Yes, okay. And then U1, B2, U1, B2 minus U2, B1. And then we plug. Plug in. This is B1, B2, B3. So a lot. Let me see. A little bit long over here. So what? U2, B3. let me say this is B3, this is B2, this is B1, right? Okay, so and therefore U2 B3, U2 B3 are directly distributed. So U2 V1 W2, right? And then minus U2 V2 W1. Okay, so that's the first. And then minus U3 B2. So B2 is there in the middle. So minus U3 V3 W1. Negative, negative makes positive. U3 V1 W3. Okay, so I finally get the first. See? And this is the first. Okay. And then the same, we'll look at the second. I have to get it up a little. The second is a U3 B1. Okay, what is B1? Okay, so this is a B1, right? So let me just put something. So I'll put it here. So what is B1? It's B2 W3 minus V3 W2. What is B3? B3 is V1 V W2 minus V2 W1. Okay, and later we need the B2, so that means they are put here B2. So V3 W1 minus V1 W3. Okay, so now I can calculate. So U3, the second is U3, right? V1. So V2 W3 minus U3 V3 W3. No, W2, sorry. The minus U1 times B3. U1 V1 W2. Negative, negative makes it positive. U1 V2 W1. Okay, and then we finish the second. And then what is the third? The third is a U1 times B2. Be patient. Let me copy V3 W1 minus U1 V1 W3. Okay, and then minus U2 times B1. Well, B1 is there in the middle, which is V2 W3. Negative, negative makes a positive again. So U2 V3 W2. Okay, so good. See, can we simplify? I don't think so. So we leave it here. Okay, so we leave the result here. So now we keep this, let me say, the first. Okay, so we calculate it. I calculated the left side, and the left side equals this complicated vector. Now, what do? I will work from the right side, and then to the same complicated vector. What's the right side? So U V minus W. Okay, V minus W vector. I can copy. So UW UV. Okay, so U. Now calculate what? I calculate U dot W times V minus U dot V. U dot V, yes. And then W, which is the right side. Okay. This is not complicated, so we can calculate directly. What is the dot product? Let me get dot product, which is a number U1 W1 plus U2 U2W2 plus U3W3 times V. Let me put the V. V is a V1, V2, and the V3, right? Okay, so minus. Dot product of V and the U, which is U1, V1, U2, V2, U3, V3, then times the W, which is W1, W2, and W3. Okay, do normal calculation. See, I should get a long, big. So first, this is a number, right? So you can put it this here. The first, the second, the third. That's a scalar multiplication. Okay, and then we do subtraction. First is scalar multiplication. The second is subtraction. Okay, the difference. Therefore, I should find the difference. The first component is long. Let me write U1. Let me put the V on the second position, which is V1, W1. Okay, and then plus U2 V. Sorry, no, I get it wrong. I skip one step. I know I will not skip the step. Let me direct it. Not skip the step. So because too long, I skip one step. So I find that the first component should be all these times V1 and then times minus all this times W1. Okay, so how many times? 6 times. I write the 6 term down. U1, V1, W1. Good. Yes, and the second, which is U2, V1, W2. Plus the third, U3, W. I will switch the order, which is V1, W3, and then minus. So 3 terms positive and then 3 terms negative. So negative is U1, V1, W1 minus U2, V2, W1, or the W1, and then minus the last is U3, V3, W1. See, the first component is long. Okay, this is the first component. Okay, can we simplify? I think so. Yeah, look at U1, V1, W1. See, this term the same, so we cancel. Therefore, we have only how many terms? 1, 2, 3, 4 terms left. Only 4 terms left. Good. And then can you compare this term? Okay, to that it should be the same, right? Let's compare a little later. Let's finish another 2 terms. The second term. Second component, which is we use this V2 and then minus W2. Okay, after the scalar multiplication, which is U1 V2 W1 plus U2 V2 W2 plus U3 V2 W3. Okay, and then 3 negative terms. So U1 switch. V1, yes, W2, then minus U2 V2 W2, then minus U3 V3 W3. See the second component, and then the last component. Okay, so you can copy the last component that we need to use this one and this one, right? Therefore, is U1 V3 W1 plus U2 V3 W2 plus U3 V3 W3 and then minus U1 V1 W3 minus U2 V2 W3 minus U3 V3 W3. Yes, finally we got it. Let's simplify the second term. Again, U1 V1 W2. No. U2 V2. Yes, U2 V2. Yes, we do this term, right? And this term we can cancel. They are the same, right? Okay, the same. Look at this term and this term we can cancel. Okay, so finally, what do we have? We have 1, 2, 3, 4 terms is the first component. 1, 2, 3, 4 terms the second component. 4 terms for the third component. Do you think this vector is equal to this first vector in the equation 1? We can compare. See, 4 terms, 4 terms, 4 terms. 2 positive, 2 negative. 2 positive, 2 negative. 2 positive, 2 negative. 2 positive, 2 negative. Okay, and then let's just verify the first positive term. U2 V1 W2. U2 V1 W2 here. Okay, the second positive. U3 V1 W3. Okay. U3 V1 W3 exactly the same. And then you can verify the negative. The negative should be the same. And therefore, this is exactly, okay, equals. This is exactly equals the vector, okay, the vector in the equation 1. Okay, equation 1 we find. See here the same. What do we get? So we worked from now. We worked from the left. We get a vector in the. We get the same vector in the middle. We work from the right to the middle is the same. So therefore, the left should be equal to the right, right? Okay, so that's the proof. Thank you.